All right, the last video we have for you today is the most confusing. It's not going to be super long, but these are hard problems. There's only 3 problems, okay? But they're difficult. So if we're looking at something like this, number 38, we have transformations of 2 to the x. We're trying to describe that transformation. That can be difficult, okay? There's a couple of ways I like to start. I like to start by looking at growth, decay, up, down. Let's think about negatives. And let's think about the asymptote. So first off, what does the asymptote look like on number 38? The asymptote looks like it's at y is equal to 1, right? So there's some kind of vertical shift up 1. That's where we're going to start. For 39, the asymptote looks like it's around positive 3. That's where we'd start on that one. For 40, asymptote also looks like it's at positive 3. I think it's getting really close to, but never touching. Let's start by writing that down. All right. So for something like 38, all right, you're going to say, okay, our asymptote is going to be y is equal to positive 1. That's a vertical shift up 1. So in our guess, we're going to have y is equal to something, some transformation of 2 to the x, and there's going to be a plus 1. But this is not our answer, right? But that's where we're going to start. This is not our answer because this is exponential growth going up. But look at what we got over here. This thing's not going up at all. This thing's going down, right? It's going down to infinity. Instead of going up, it's going down. But it's still diving. That's some sort of vertical reflection. It's upside down from our normal exponential function. You might say, well, what is our normal exponential function, right? Remember that this right here is what standard exponential function looks like. The situation we have in 38 is the upside down version of that. Right? It's still leveling off on the left. Still leveling off on the left. Instead of going off to positive infinity on the right, it's going down to negative infinity. So that's a vertical reflection. Flipped upside down, it's a vertical change. That means the negative goes on the outside. If it were flipped left to right, the negative would go next to the x. Okay? So let's see. So we got the right shape. We got the right asymptote. At this point, this is where it starts getting a little trickier. You have to say, okay, was there a horizontal shift? None of these are getting stretched at all. So the question is there a horizontal shift? If so, we need to incorporate that. If not, we're done. So let's kind of just check our answer. This function, this graph, goes through the point 0, negative 3. All right, the graph goes through the point 0, negative 3. Well, let's see what our graph does when x is 0. Our graph when x is 0 is negative 2 to the 0 plus 1. Again, be very careful with order of operations. That's going to be negative 1 plus 1, which is going to be 0. So ours goes through 0, 0. That's not good at all. Okay. Ours goes through 0, 0. Theirs goes through 0, negative 3. So we didn't do it. Okay. We are going to have this horizontal shift. Again, ours went through 0, 0. Theirs went through 0, negative 3, 0, negative 2, but we're looking for a horizontal shift here. So if 0, 0, what point do we have to horizontally shift to get it on the graph? We have to horizontally shift it left 2 units. Okay, that's going to be a plus 2 right there. Okay, so this is what I think it's going to be. Now let's check our answer again. So we updated the function. Let's see what it does now. When x is 0, we have negative 2 to the 0 plus 2 plus 1. That's negative 4 plus 1. That's negative 3, which is exactly what we wanted. Okay. So it's really an iterative process to approach these. Start with the asymptote. That'll be a vertical translation. Then get the shape right, and then look for horizontal shifts. We're going to do number 40 as well. And then you can check your answer for number 39. For number 40, start with the asymptote. Asymptote's y equals 3. Right off the bat, we're going to say, okay, asymptote's y equals 3. That means that there must be a shift up 3. Must have gone up 3. Okay. And then some other things to think about is, what is the shape? Well, it's not the same shape as before, and it's certainly not the same shape as our normal 2 to the x function. Right, 2 to the x looks like this. Levels off on the left, and it goes up on the right. Whereas here, it levels up on the right and goes down on the left. So it's backwards in 2 different directions. Right? Instead of going up like this, up on the right, level off on the left, it's leveling off on the right, going down on the left. So it's actually getting reflected about both axes. Reflected around both axes means we're going to have a negative next to the x and a negative out in front. Right? And again, this is tricky stuff. I recognize that. If this is on the exam, it will be worth a small amount of points. Okay? But it is important. So at this point, we need to check for horizontal shifts. All right? Check for horizontal shifts. Those are the hardest to see. There are some shortcuts of doing it, but I think the best way to do it is kind of check. Let's look at a point on here. Point on this graph is 0, 1. Let's see, are we at 0, 1? So our graph is 0, 1. And if this is 0, 1 too, then we're probably good. All right, so ours, if x is 0, we're going to get negative 2 to the 0th power plus 3. That's going to be negative 1 plus 3. That's going to be 2. All right, so we have the point 0, 2. It's kind of close, but not quite. So we have the point 0, 2. What horizontal shift do we need to take to get what we have, 0, 2? What horizontal change do we have to make to get to the graph? 1, 2. So we were right here. If we moved our thing right 1, then we'd be good to go. So we want to move it right 1. Okay. This is where you have to be a little bit careful. Normally to move something right 1, right, you do something like this. Subtract 1. But remember back to the order on which we usually write function transformations, right? The order we normally do is horizontal shift first, vertical shift last, and everything else in the middle. So since we already did something, it's not actually going to be a -1 as we think. Since we already added that negative, it's going to be the opposite. It'll be +1. But again, don't take my word for it. Check your answer, right? Again, let's see if our new thing, so this was our old one. See if our new thing has 0, 1. If x is 0, you're going to get 0 plus 1 like this. It's negative 2 to the 1st power. This positive 1. Okay, so we are on the point 0, 1 now. And you can check more points and make sure you're right. Okay? But the order really matters, and it will sometimes make things go backwards if you do things in a different order. All right? So this is tough stuff. Feel free to let me know if you have any questions. And remember that in addition to these videos, you do have other videos as well. Okay? Right above the exercises to all these sections, there are links, and you can
Welcome to a video
can
on
watch
exponential
an assortment
functions.
of random people.
The goal of this
things.
video will be to graph exponential functions.
All right. That's it for this section. Let me know if you have questions.